So here we have truss structures. So truss supports pin support support G and roller support at H. And there are three horizontal loads. So we have H1 equal to 30 kilonewton, H2 equal to 72 kilonewton, and H3 equal to 15 kilonewton. We also have two vertical loads. So V1 is 15 kilonewton, V2 is 28 kilonewton. And the question is, what are the tension force in the member CF and DF? So we want to know the member force in CF and DF. Here we can using method of section to solve it. So to use method of sections, first of all, we need to cut through the section. We need to cut the truss into two parts. So because we want to load CF and DF, so we make a cut along CF, DF, and CE. So after we make a cut, we have two choices to do analysis. So after we make a cut, we have the first choice, we do analysis on the upper part of the cutting. So if we do analysis on this part, we will have the member force. Here is FCE, member force FCF, and member force FDF. Okay, this is the first choice. The second choice, we can do analysis on the bottom part. So if we do the analysis on the bottom part, if we put the member force over here, is FCE, FCF, and FDF. So you can either choose the upper part or the bottom part, but here we choose the upper part, because if we choose the bottom part, we need to first determine the reaction force. We have three reaction force need to determine. But here, if we choose upper part, we don't need to derive the reaction force. So let's look at the upper part. So for the upper part, for this part, we can write down three equations of equilibrium. So because we want to know the FDF and FCF, and first of all, the first equation of equilibrium we can write down is, we can write the moment equation of equilibrium at the point C equal to 0, because we find FCE, FCF go through this joint C. So if we write down the equation of equilibrium at the joint C, we don't need to consider FCE and FCF because they have zero moment at this joint. So if we write down the moment equation of the joint C, and we assume the clockwise direction moment is positive. So look at the joint C. First of all, we have H1. So H1 have a bending moment at the joint C. So we have H1, and the lever arm is 1.5. So H1 is go through clockwise, so it's positive. And then we have V2 have bending moments at joint C, so it's also positive. So V2, the lever arm, is 2 meters. And then the last one is FDF have bending moments at joint C, so it's also go to clockwise. So FDF and the lever arm is 2 meters as well. Okay, equal to 0. And we know H1. So we know H1 is 30 kilonewton, showing here, and V2 is 28 kilonewton. So we will apply these two values. So H1 is 30 kilonewton times 1.5, and V2 is 28 kilonewton. So V2 is 28 kilonewton times 2 plus FDF, we need to know, times 2 equal to 0. So then we can, from this equation, we can derive FDF is equal to negative 50.5 kilonewton. Okay, so this is the force at the member FDF. Then we need to know the FCF, member force in CF. So to know MCF, and we can write down the equation in horizontal direction, the equation of moment in horizontal direction. So that is Fx equals 0. So if we see the horizontal direction go to right is positive, so in horizontal we have H2 is positive, and H1 is positive as well, and the another horizontal force is the component of FCF. The component of FCF is, so this component have value is FCF times cosine theta. So if this is theta, okay, then the third horizontal force is FCF times cosine theta, and that's all the horizontal force. So horizontally this force equals 0, and we know H2, so H2 shown here is 72 kilonewton and H1 is 30 kilonewton. So we plug in here, we'll have 72 kilonewton plus H1 30 kilonewton plus FCF times cosine theta equal to 0. And then we need to know what's the value of cosine theta. So the angle theta is showing here. So if we see, let's look at here. So this is the theta. This is the angle theta. So the cosine theta, so cosine theta is equal to CD over CF. Okay, CD, so look at here. So CD is 2 meter. And CF, if in this red triangle, so we know CD, we know DF, and CF can be calculated is the, so CF is square root of 2 square plus 1.5 square and equal to 2 over 2.5, so is 0.8. Okay, so this is cosine theta. After we know the cosine theta, so we put cosine theta over here. The value is 0.8. Then we can derive FCF is negative 127.5 kilonewton. Okay, so in this question they ask for, so round to 3 significant figures. Okay, but here we have 4 significant figures. So if we write down to 3 significant figures, we will have FCF approximately equal to negative 128 kilonewton. Okay, so this is the value, the member force in DF and the member force in CF. Okay, so because we ask the tension force, so we must keep negative sign over here, keep a negative sign over here. Okay, so this is the solution for these truss structures.